So tomorrow morning, there's only going to be two of us. Are we just going to come and do a working lesson, or?
What about?
I won't go on permutations tomorrow then. I'm going to.
I could use an extra hour of sleep.
Just laugh.
So I won't be continuing anything tomorrow. Probably come in and do some work.
Yeah, maybe. Depends. That's why I wasn't here yesterday either,
We can catch up on that work.
because I was in hospital on the night that night. Yeah. Because of my toe.
What did that surprise me? Alright, so we have the examples on page. Recording here. Right, examples on page 48. Okay, so the first one, sign of 44. So again, you need to be able to remember this table, learn the table off by heart, or you need to be able to derive them quickly from last lesson's work. Okay, and the video will be up there this afternoon. So, reading off the table, sine of 45 degree is, the exact value, is 1 on root 2. Right, the second one, B, tan of 150 degrees. So we need to write down the exact value of this. So, like I said, if you understood the process of getting all of the, where the ratio is positive in each quadrant, this will make this work much easier. Okay, so an angle of 150 degrees is in which quadrant? Second. So a general angle theta, like we did with last lesson, okay, is going to be from tan of 180, take away that value theta. Okay, so we need to be able to take away a number from 180, and it gives us 150. Okay, so we've got 30. Okay, so tan of 150 is equivalent to tan of 180, take away 30. Okay, so this is what's called the basic angle. Alright, so BA, basic angle, alright, is equal to that 30 degrees. Alright, what you had to subtract to get to the correct reading over here. Alright, after you've done that, you then need to consider those quadrants. Alright, so all students take calculus. So, in the second quadrant where we are, tan is negative. Okay, so that means your tan of 150 is equal to negative of tan of that basic angle. Okay, so the basic angle is 30 because we had to go in the second quadrant. An angle in the second quadrant was 180 take away that base theta. Okay, so that value theta is 30, which is what's called the basic angle. Alright, 30 degrees. You then need to consider your quadrants. Alright, so 150 degrees in the second quadrant, and only sine is positive. Okay, so tan of 150 degrees is the same as negative tan of that basic angle up there. Okay, so what is tan of 30? Okay, so tan of 30 is 1 on root 3. So tan of 150 degrees will be negative 1 on root 3. Okay, because of the angle in the second quadrant. Alright, so this is all new, and you will understand it better once I go through some more examples and you have a go yourselves. We're done? Yeah. Alright, C. Alright, cos of 210 degrees. Okay, so we need to write the exact value using your sine, cos and tan of 30, 45 and 60 to write the expression for cos of 210. Okay, which quadrant is the angle of 210 in? Third. Okay. So, to get an angle in the third quadrant, like we've done when I derived it yesterday, you have to do 180 degrees plus that angle. Alright, so I'll start with 180 plus. So what do I need to add to get to 210?
30.
30. 180 plus 30 equals 210. Okay, so what you've added or you've subtracted becomes the basic angle. So basic angle is 30 degrees. So we're going back to the first quadrant. Okay, so an angle in the third quadrant is equivalent to an angle in the first quadrant, and then we also need to consider the sine. Okay, so you then draw a quick diagram labeling this. So you're going to get very good at that diagram because you're going to spit it out so many times. Right, it is the third quadrant we're referencing. Okay, only 10 is positive. Okay, so cos of 210 degrees is going to equal negative cos of the basic angle, 30 degrees. Okay? Right, so what's cos of 30? Okay, so cos 30 is root 3 on 2. So negative cos 30 is negative root 3 on 2. Okay, so if you were to go to your calculator, you put cos of 210, you're going to get a irrational decimal, okay, but it will be negative as well. So if you go cos of 210, okay, and then if you then go negative root 3 all over 2, and put that in the calculator, get the decimal, those two decimals will be equal. Okay? Right, are there any questions on that?
No.
No? Are we following somewhat what was happening? So like I said, do some more, we'll get better. Right, cos of 300 degrees. So, you need to first consider what quadrant that's in, and then write an expression relating to that quadrant from yesterday's derivation of the quadrants. Okay, so 300 degrees in what quadrant? 4. Alright, so an expression for an angle in the fourth quadrant is 360, take away that basic angle. Okay, so what will that basic angle be? 60. Okay, so 360 take away 60 will equal 300. Okay, so that basic angle, the angle we're working on, is 60 degrees. Alright, so once you've identified that basic angle, which will probably be your first mark on this sort of question, you probably worth 2 marks. Alright, you then draw your number plane. All students take calculus. Alright, so we're on the fourth quadrant for an angle of 300, and cos is positive. Okay, so when cos is positive, so therefore cos of 300 degrees is going to be the same as cos of the basic angle in the first quadrant. Alright, so what is cos of 60? Half. Okay, now in a graphical sense, alright, so if I were to do a quick graph of the cos curve, okay, so it starts up here, it's a sine curve shifted by 1, that's 360, alright, and it's symmetrical, okay, so keep going that symmetrical pattern. So cos 300, which is 60 degrees less than the revolution, and our basic angle is the same distance to the right from the origin. Okay, that means those two values are going to be the same. Okay, you're going to consider the y value. Okay, that's what this work's covering. Alright. So it's a new way of thinking and new things happening in this topic. Alright. Put that down. Alright, E. Alright, 10, don't do capitals, 10 of 600 degrees. Alright, so what's the first thing I need to consider for this angle? Because there's a difference between this one to what we've already been working on.
Big angle.
It's bigger than the revolution, isn't it? Okay, so what can I do with that angle there to make it more appropriate for answering this question?
Take away 360.
Good, okay, so you do the revolution, 600, you take away 360, okay, you're going to get the same spot on that number plane, just the magnitude left. Alright, so we've got 600, take away 360, alright, which is going to be 240. So 600 degree, so 600 degrees is the same as 240 degrees on a revolution. Okay? The tan 600 is the same as tan of 240. Okay, so now we've gone less than that revolution, we can now identify the correct quadrant. Okay, so which quadrant is tan 240?
That one would be third.
Okay, so 90, up to 90 in the first, up to 180 in the second, up to 270 in the third, and the revolution on the fourth. Alright? So this equals tan of an angle in the third quadrant is going to be 180 plus a basic angle. Okay? So 180 plus what equals 240? Hint is going to be 30, 45 or 60. Okay? Because we are asked for the exact value, okay, so we're only going to have those three to work with. Alright, there are no other exact values unless you go 90, 180, 270 and so forth. Okay? Alright, so the basic angle is what you had to add, which was that 60 degree. Alright, consider your number plane, or student take calculus. So which quadrant were we referencing again? Third, okay, and tan is positive. Alright, so tan of 600 degrees is going to be equivalent to tan of the basic angle in the positive direction. So tan of 60 is root, which is root 3. Okay? So tan of 600 is equal to root 3. Okay? So again, if I were to do my graph, I have to go right out to 600. Okay? Mark that point, and then I'll go do the same thing at tan of 60. Mark that point. They'll be in the same horizontal plane. Alright? And that's what we're doing because there's a symmetry of all those three trig graphs. Alright, sine of negative 30 degrees. Okay, what would be something we could write straight away? Not sine 30. No, not sine of 30. Negative what? Nope. Okay, so you've got to consider this. So, if I'm going around in an anti-clockwise direction, I get my angles bigger and bigger. So negative 30 is an angle going back that way there. So what's the positive equivalent? Okay. Sine 330 degrees. It is an angle in the fourth quadrant. Okay, which is sine of an angle in the fourth quadrant, which is 360, take away that basic angle. So yes, you will get negative 30, negative half as your answer. I'm not so convinced that it will always work. Alright, so basic angle is equal to 30 degrees. Alright, quick sketch, consider showing them that you are considering the sign of your answer. So you are in the fourth quadrant and only cos is positive. Alright, so sine of negative 30 degree is going to be equivalent to negative sine of 30 degrees. Alright, so sine of 30 is half, so negative sine 30 is going to be a negative half. Right, question before we move on to the next couple of types. Right, everyone finished with the notes? Alright, something slightly different. Alright, so G. Right, so the question's slightly, not slightly, a bit more different. So you have the condition cos of theta, which is negative 3 on 5. Okay, and we also told that tan of theta, which is greater than 0. Okay, we need to find the values for sine of theta and cot of theta. Right. So, any ideas what I can do to answer this question? Alright, so where would cos of theta equals 3 over 5 come from? Pardon? So if I were to write down cos theta which is equal to 3 over 5, where would that could have come from? If I was writing an answer.
Oh, triangle.
A right angled triangle. Let's draw that please. Okay, so put the right angle and theta somewhere in the triangle. Obviously right angle has to be in a specific spot. Put theta somewhere in there. Okay, now cos of theta. So we've got the hypotenuse, we have the opposite and the adjacent. Cos of theta which is equal to 3 over 5. Right, well, I'm just ignoring the negative sign for a moment. So 3 and 5 on the adjacent and the hypotenuse. Okay, tan of theta is greater than 0. So, now what we need to do is draw the quadrants and where the ratios are positive. Okay? Right, so cos of theta is negative. Alright, so cos of theta is negative. It is negative in the second and the third quadrant. Alright? Tan of theta is greater than 0. Okay, so that means tan is positive in the first and the third quadrant. Okay, so we are now referencing the value of the angle inside the third quadrant. Okay? Right, so using that, we answer our question. Sine theta, which is opposite over hypotenuse. Alright, so I've got the adjacent or hypotenuse, I don't have the opposite. Alright, so you need to do one of two things. You need to use, well, you wouldn't do trig twice. You wouldn't find the value for the angle here and then take the sine. Alright, what's the alternate way with right angle triangles? Pythagoras. Okay, can someone tell me right now what that value is? Four. Pythagorean triad. 3, 4, 5. So 25 take away 9, which is 16, go to 16. Okay, so sine of theta, which is opposite over hypotenuse. Okay, so we have opposite, which is 4, hypotenuse, which is 5. However, we are referencing an angle in the third quadrant where only tan is positive. Okay, that means this is going to be a negative 4 over 5. Okay, got another question on the same principles to look at. Oh, we'll do cot. Alright, cot of theta, what's the two letters? Alright, so normally for tan it will be O over A. The cot is the reverse of that. Alright, cot is the reciprocal of tan, so we are in the correct quadrant in terms of it being positive. The answer is going to be positive here. So adjacent, which is 3, and opposite, which is 4. The cot theta is going to have the value 3 over 4. Right, let's try another one. We've got that down. Alright, so we've got H. Alright, so you were told that tan of theta is equal to negative 2 over 7. And we're also told that cos theta, which is less than 0. Okay? We need to find the values of sine of theta and cos of theta. You're only told that it's negative. Okay, so you need to actually write down the value. Alright, so remembering, if you ignore that minus sign, this tan of theta equal to 2 over 7 would come straight from your right angle triangle trig. Alright, so what you need to do is draw that triangle. Reference theta somewhere in the diagram. Right, so let's get the three sides, hypotenuse, opposite and adjacent. So tan is opposite over adjacent. Alright, so this side is 2 and that side is 7. Alright, ignoring the sign for a moment. Alright, so you then go to your quadrant. All students take calculus and then you consider the condition. So tan of theta is negative. So which two quadrant is tan negative? Okay, so it's negative in these two quadrants. Okay, so you need to see where they overlap, and that's where the second condition tells you. Cos of theta, which is less than 0. Alright, so cos is negative in the second and the third quadrant. Okay, and they both overlap in the second quadrant. So that is the reference point for your answers. Okay? Right, so we need to write sine theta, and we also need to write down a value for cos of theta. So sine of theta, which is opposite over hypotenuse. So we have the opposite, we don't have the hypotenuse. Okay, and Robin, this is the one where you're at. Alright, so 7 squared, 49, 2 squared, which is 4, square root of 49 plus 4, which is square root of 53. I do not believe you can simplify that any further.
No.
Pretty sure 53 is a prime number.
Can't go on any further.
1, 4, 9, 16, 25, 36, too big. Yep, so that's in the simplest form. Okay, the sine theta is opposite over hypotenuse. So 2 over the square root of 53. Alright, and we are referencing in the second quadrant, so this fraction is going to be positive. Okay, cos in the second quadrant, cos is negative. Alright, so A over H, and the second quadrant cos is negative. Alright, so A is 7, H is square root of 53. Now, in the past you have covered the skills of rationalising the denominator. Okay, this question is not requiring you to do so. Okay, only if the question asks you to do so is when you go ahead and rationalise. Okay, otherwise I'm just testing on the ability to write the correct fractions. Okay, not that you are going to write them with a rational denominator. Okay, alright, so 6.7 can now be attempted. Alright, I'm not going to continue on. I'll continue on next lesson.
Did I say